Oh, look at me, 4. Concentration of reactants. So the higher the concentration, the faster the reaction. Okay. Just a note here. Okay. Because the number of moles of particles in a solid is directly proportional to volume. It's directly proportional. Moles is directly proportional to volume. The concentration of solids and pure liquids can't change. Do I need to explain this more in detail?
Can I say it's constant?
Yes, the concentration is constant. Okay? Do I need to explain it with more concrete example?
Mm-hmm.
Okay. Water is a very good example to use. Okay, so if we've got 18 milliliters of water, what is the mass of the water?
18 milligrams. 18
So
grams.
the volume of 18 milliliters of water has a mass of 18 grams. And how many moles do you have if you've got 18 grams of water? You have 1 mole. Am I right? Okay.
Why?
So,
Why?
because the molar mass of water is 18.
Oh.
Yeah, and the beautiful thing about water is its volume is also, its volume and its mass would be the same. 18 milliliters of water will have a volume of a mass of 18. Okay, so you'll have 1 mole. So what is the concentration of the water? It will be the moles divided by the volume, which is 1 divided by 18. 18 is the milliliters. So what is the liter, or the cubic decimeters? So 18 milliliters is 0.018 liters. So it is 0.018 cubic decimeters. So 0.018. If you want to Cassiopeia that quickly, we can get the concentration of water. I think it's 55 something, if I'm not wrong.
It's 55,55.
Yes. 55. So this 55.56 mole per cubic decimeter is a constant value. Let's work with it. Let's double up the volume to 36 millimeters, which is 0.036 cubic decimeters. What will the mass of the water be? It will also double to 36 grams. How many moles would you then have? You'll have 2 moles of water. So what will the concentration of 2 moles water be? It will be 2 divided by 0.036, which is exactly 55.555 into eternity, which we have rounded to 55.56 mole per cubic decimeter. So pure liquids like water, if it's a pure liquid, its concentration can't change. So when you'll see later on, you'll understand why I'm stressing this point now. Because we said concentration of reactants affects the rate of a reaction. I want you to understand that a liquid's concentration can't change. The hydrochloric acid we used was a mixture, not a liquid. That's why its concentration can change. And a solid, I also want to refer to a solid. So solids, like the calcium carbonate we have here. The calcium carbonates, if I've got 1 mole of calcium carbonate, I'll have 100 grams of calcium carbonate. Now, I haven't measured the volume of calcium carbonate, but I think you can understand that it will have a specific volume. And if I double up the mass, what will happen to the volume? If the mass is doubled, then the volume will also double. Okay? If the mass of a solid is doubled, then its volume will also double. So what will happen to the concentration? It will be a constant. Yes. Good. So that was the first one. Can we go to the next one? The second factor was the state of division. Some people say the surface area of the reactants. So the greater the surface area, or the bigger the surface area, or you could say the finer the particles, the faster the reaction, or the higher the rate of the reaction. Coming.
You overslept.
A stomach ache and then
What happened?
stomach ache.
Oh, yeah. Okay, the third one is, the
Temperature.
the temperature. So the higher the temperature,
The faster the reaction.
yes. You could say the faster the reaction or the higher the rate. And the fourth one was the nature of the reacting substances. And here we could say that silver nitrate and sodium chloride reacted faster than the calcium carbonate and the hydrochloric acid. If I can go back to concentration, we think concentration is only the moles per volume with liquid solutions. But you also have, when you have gases, you actually just increase the pressure on the gas and then the concentration will change. Because the volume gets smaller, concentration and pressure has the same effect. So the higher the pressure that the gas experiences, the faster the reaction will be. Can you remember me naming or mentioning the Haber-Bosch process? You can't remember that. Okay, we're going to talk about it this year again. I've just done it with the grade 11s, where the reaction between nitrogen and hydrogen takes place at 450, 550 degrees Celsius, so it's rather hot for us, and a pressure of 200 atmospheres. That's a high pressure. And the reason, and those two factors combined gives a 15% yield of ammonia. So if they reduce the pressure in the reaction chambers, the reaction will even produce less ammonia. So increasing pressure also affects the rate of the reaction. Maybe we want to write that somewhere. And then the last thing, you are very clever, you just didn't think of it. What speeds up a reaction? A catalyst. A catalyst speeds up the reaction because it reduces the activation energy. So those are the things that we need to add to this. So if we have gases, shall I call it 5 without you being confused? For gases, increasing the pressure will increase the rate of a reaction and then the sixth factor is catalyst. Adding a catalyst will increase the rate of a reaction.
Put your head out. I want to take my